Hello, myself Sonali Kesalwani and I am a fourth year BTech student of NIT Lab. We are gathering here to study an important topic of JEE Mains and Advanced is semiconductor. So today we are discussing about the topic introduction, type of materials on basis of electrical properties, type of semiconductor, types of extrinsic type semiconductor, valence bond model of semiconductor, and energy band diagram. Semiconductor is a material with electrical conductivity lie between a conductor and insulators. Its unique property of controllable conductivity make it cornerstone of modern powering devices like smartphone, computers, and key features of semiconductors is conductivity is neither more uh, or not low as its insulators. It increases with temperature as in metals or conductor the conductivity is neither increases, but in case of semiconductor the conductivity is increases with temperature. If we discuss that energy band of semiconductor is energy band gap of semiconductor is between 1 to 2 electron volts, which is between the valence band and conduction band. If we discuss the classification of material or solid on the basis of the electrical properties, it will be classified into three parts: matter or conductor, semiconductor, and insulator. Conductor is a material that allows the free flow of electrons resulting in high electrical conductivity. So, the few of the characteristics are it has very low electrical resistance, means the resistivity would be in range of 10 to the minus 2 to 10 to the minus 8 ohm meters, and because of large number of free electrons in the conduction band, its conductivity is more. For example, copper, silver, gold, and aluminum are the few elements which are used as a metal or conductor. Its applications would be electrical wiring, circuit connectors, etc. If we discuss the insulator properties, the insulators mainly are those that do not conduct electricity due to the absence of free charge carriers in their conducting bands. Later on, we are discussing about valence band, conductive bands, and energy band diagram. And it has highly electrical resistance, which is about 10 to the power 8 ohm meter. Examples are rubber, glass, wood, plastics are the few insulators. Insulators are used for circuit protection and electrical insulation. If we discuss about the semiconductors are those whose conductivity lies between conductor and insulators. It has moderate electrical resistance, means electrical resistivity lies between 10 to the power 5 to 10 to the power 0 ohm meters, and there would be a very less energy band gap, that is about 1 to 2 electron volt band gap between valence band and conductive bands. For example, silicon, germanium, and gallium arsenides are few of the elements are used for semiconductor purpose. Applications are diode, transistor, solar cells, or integrated circuit. Now, there are two types of semiconductors are there on base of doping: intrinsic type and extrinsic type semiconductor. Intrinsic type semiconductors are also known as pure semiconductors that is not doped with any impurities. It has a tetravalent crystal only. The conductivity is very low. It is composed of a single materials and having an equal number of electrons in the conduction bands and holes in the valence band. Electrical conductivity is low at room temperatures but increases with temperature because more electrons can jump into the conduction band. Applications is basic semiconductor properties, research and some early electronic device. Now, extrinsic semiconductor. Extrinsic semiconductors are also a tetravalent crystal doped with pentavalent and trivalent elements. So, mainly a semiconductor that is intentionally doped with impurities to alter its electrical properties. So, main function of doping is to alter its electrical properties. Characteristics. The conductivity of extrinsic semiconductor is significantly higher than that of intrinsic semiconductor because impurity atoms introduced during the doping process increase the number of charge carriers. Charge carriers, it may be holes or electrons. The permitted energy stack of impurity atom between conductive bonds and valence band. In N-type and P-types are two types of extrinsic type semiconductors which we are discussed later in this video. N-type and P-types are the two types of extrinsic semiconductor. N-type semiconductor or negative type. In N-type semiconductor, electrons with more valence electrons than the semiconductor, example, phosphorus, arsenic or silicons. In these, extrinsic semiconductors are doped with pentavalent elements that are phosphorus, arsenic, for silicon. Mechanism is the extra electrons from the dopant atoms becomes a free electrons which